Hi, you just saw some gameplay footage from a game I published in Miliastra Wonderland called Project Descenders. In this video, we're going to learn all about the projectiles that I used in this game, how I set it up in the skill editor, and hopefully by the end of this video, you'll be able to create your very own projectiles and skills to be used in your own shooting games. Let's dive into the editor and get started. Alright, so once you've loaded into the Miliastra editor, the first thing that we want to do is to create the projectile. So in shooting games, projectiles are basically your bullets. In order to do that, you want to choose the fourth tab in the top menu, and it'll take you into the combat preset tab. In here, you have 5 options. The first thing that we want to go into is the local projectile tab, which is the fourth one from the top of the left side menu. Go ahead and click new projectile, and it will ask you for a name for your projectile. In this project, let's call it Pyro Orb, as we will be making a pyro projectile. Choose a folder you want to go into and click confirm. Once you click confirm, it will take you to the projectile settings of the projectile that you just created. Now, as you can see, the default model is a wooden box, which is obviously not what we're going for, so go ahead and look to the right side of the screen and look under basic settings. Click on the wooden box, and it will show you 5 options. We have wooden box, dirty fruit, toy block, potential energy orb, and the one that we're actually going for and choosing from this is empty object. Now, we will be able to define later on the visual effects that will represent our projectile, so leave that as empty object for now, and look to the next option right here, which is native collision. Let's set the initially effective to off in order to avoid unnecessary or unwanted detection from your projectile. Next is battle parameters. The default is just inheriting whatever your character's attribute is, the HP, the attack, and the defense attributes. For this project, let's leave it on to your default settings. Next is life cycle settings, which is basically how long and how far your projectile will travel. Now, if you set this permanent to off, you will have to put in a duration in which your projectile will stay in the scene. For this project, let's turn it into permanent. Don't worry, the projectile will not stay in the scene permanently. We will be able to add an ability unit later on that adds a self-destruct to our projectile once it reaches the maximum distance that we set the XZ component and the Y component axis to, or once it reaches the target, whichever comes first. So for now, let's set up the maximum distance that we will allow our projectile to travel. For this one, I'll set it up to 50. Go ahead and save that. And after that, we will go to our second tab, which is where we will see 3 more options. We have VFX playing, projectile motion device, and on-hit detection. Let's first go into VFX playing, and basically, this is where we will add the visual representation of our projectile. Uh, Go ahead and click Add Effects over here. Click to select VFX effects, and since we're going for a pyro projectile, go ahead and click the filter right over here and click on pyro. Click on confirm filter and it will show you the different pyro effects that are available to use. Uh, let's take a look at pyro projectile. Click on play to see what it looks like. Right, it seems good, so I will just click on it and you can see that it shows up right here now. We want to leave the sound effects on and also the follow location on. The follow location follows the projectile motion device that we will set up next. Right, leave the rest as is. You can change the zoom factor if you want it to be a really big projectile. You can set this up to 2 and it will double the size. You can also make it smaller if you want to resemble more like a bullet. You can set it up to 0.5 or even smaller. For this project, let's just leave it at 0.75, and that should be good. Exit out of the VFX playing editor. And next is we want to set up the projectile motion device. Now click on advanced setting, and here it will show you the projectile motion device settings that we want to set up. Under basic settings, we can set up the projectile type. For the bullets, we want to set or we want to choose linear projectile. For linear motion configuration, this is basically the speed at which the projectile will travel. Since we're going for bullets, we want it set up like a really fast projectile. So um, I will set this up to 90 meters per second. That should update that. And the reason why I go for 90 is also this is a word of caution based on my experience. The engine has a hard time keeping up with a super fast object that goes over 100 meters per second, which is why if we set it up to something higher than that, then you'll more likely to experience tunneling, which basically means your projectile goes through walls, which we don't want that. So let's just set this up to 90, keep the rest at 0, and ground hugging movement to off. Exit out of that one, and we're now down to the last part, which is the on-hit detection. So go ahead and click on advanced setting. You can see two tabs here. We have on-hit rules and on-hit area. Go ahead and click on on-hit area, as that is much easier and more simpler to define. For the trigger shape, let's go for a sphere to resemble basically our projectile. So next is radius. Basically, think of this as the collision trigger of your projectile, and when any part of this area collides with an object, a scene, or a target or an entity, it will trigger the on-hit rules that we will be setting up later on. So you can set this up as small as you want or as big as you want. Um, the rule of thumb is make it the same size as your projectile. That way, it will be more consistent and it will not cause more confusion to your players. So 0.75 seems to closely resemble my projectile, so let's leave it at that. Next, we want to go back to on-hit rules, and this is where we will set up what happens when the collision area collides with an entity, an object, or a scene. Under basic settings for the trigger type, we have three options. We have single trigger, non-repeating trigger, and repeating trigger. For our bullet type projectile, let's set this to single trigger. For the detection delay time, since it's a fast moving object, we want to set this to 0. Another setting that will help with tunneling issues is enabling continuous collision detection. When enabled, this solves the tunneling issues by replacing the standard detection method. Instead of the engine just checking where the projectile is at two specific points in time, which in fast moving objects could be the difference between like a registered hit or not, the engine imagines a cylinder stretching between 2 points, and we can control how big or how small this detection radius or this cylinder is by increasing or decreasing the detection radius. Now, a good rule of thumb though is to match your projectile size with the detection radius size so that your hits still feel precise. In that case, we want to set up the detection radius to 0.75, which is the size of our projectile. Now, what happens if we set the detection radius to 0? In this case, the engine switches to ray casting. Now, ray casting is actually faster and more efficient in its process. The reason it's faster is because a ray cast only cares about a starting point and an end point. So it's basically just a single line between you and then where your camera is looking at. For the projectile that we're making today, I've set the detection radius to 0 and enable ray casting. Now, once you're done with the basic settings, you want to go over to filter settings. For today's video, we want to just focus on enable filters below option, turn that on, and now you can set the faction filter, which for this competitive shooter game, you want to set to hostile faction. This basically means that your projectile will only affect entities that are from a hostile faction. For entity type filter, you want to check which entity type your projectile will affect. Of course, you want to check the characters. If there are monsters in your stage, then you want to check creations. And if you want it to affect objects that you place in the scene, then you want to check it as well. For hit layer filter, you want to check the hurt box. All entities have their default hurt box, and this basically means that your projectile will affect that entity's hurt box. If you want to affect the scene colliders, then you want to check scene. And object self collision basically means that it will affect itself, which we do not want. But even if we check this, our projectile is moving way too fast for it to really have any effect at all. Let's leave that unchecked and go over to the on hit trigger settings. This is where we will add the ability units. We need two ability units for this projectile. One is for dealing damage, the other is for self-destruction. Now click on ability unit, and then now you can see that you can go to edit ability unit. Click on that and it will take you to this part right here, which is basically the third tab of the projectile settings. You want to click on advanced settings, click the plus sign two times since we're going to do two. And for the first one, let's rename this to hitbox attack. And the second one, we want to name this as destroy self. All right. Now, for the very first one, we want to change this to a hitbox attack or a direct attack. These two are fairly similar, only that direct attack has less parameters in it. Let's choose hitbox attack and let's go over the hitbox configuration. For base location, the best setting is to put it on hit location to make it more precise. Hitbox shape should be sphere, the same as your projectile. And again, the radius, we want it to set the same as your projectile. Next is target filter. Again, we want to set it to hostile faction. Entity type filter, objects, characters, and creations. Attack filter, we want to choose hit all. Trigger entity or trigger type, we want it to be trigger only once per entity. Once we're done with that, we want to go over to the parameters, attack parameters. Damage coefficient basically is a multiplier relevant to your character's attributes. So we could set a damage coefficient of 2, 5, whatever you want. Next is damage increment, which is basically a fixed addition to whatever the results of your damage coefficient multiplied by your character's attack. So you can set this to 200. And then elemental type, since we're doing a pyro projectile, we want to set this to pyro. Elemental attack potency adds to the final damage output of your attack. So for now, I'll just leave it at 0. For the hit type, we have several options. This actually changes the hit sound and the base hit visual effect. Um, for now, we just want to set this to projectile. The attack type, I think this is kind of like a marker that you can use as a condition in a node graph. Interrupt value, I could set this to 40 or however you want. This basically references or checks for the target character or target creations interrupt value. And if this is more than that, then it will knock back. Damage variation curve. This one you can set a custom variation. And this basically lets you create a table that changes the damage multiplier based on distance. So, say for example, you set 0, so basically you're right in front of the target, you set the damage multiplier to 100%. Now, if you choose a distance of 1, so basically when the projectile is coming from a distance of 1, then you can maybe set this to 90, and so on and so forth. So you can change this however you want. In our case, let's just leave it as the default value. So let's escape that and go and say no changes. Additional shield break, it actually removes the target shield's value before adding or calculating for the shield calculations for this specific projectile. As for shield pierce rate, it actually modifies the final damage taken of your shielded targets. Um, it will take the target shield's damage taken ratio and reduce it by whatever you put here in the shield pierce rate, and that will produce the final damage taken ratio of the target. Once we're done with the attack parameters, we want to set the on-hit performance right here, which is basically the visual effects that will play once the projectile hits a target. Now, on-hit scene effects is what happens when a projectile hits the scene. So its scenes are mostly the terrain. So in that case, since we're doing a pyro projectile, we want to find and look for pyro effects. Now, again, you can choose and filter attributes to pyro, and it will help you find um, a good hit feedback. Let's go ahead and find something that is good. And for on hit target effects, this is what happens when the projectile hits a target. So let's choose again a pyro one. And that seems a little bit dramatic. So let's find a more suitable hit feedback. Um, I think I will go with Pyro Explosion, but I think it's too big, so I will choose to reduce the zoom to 0.5. Alright, that seems more like it. And now we're done. So I'll just leave the sound effects on um, and then be done with it. After we've defined our ability units, we have to make sure that we actually add this to the projectile. Right now, we've only just defined the parameters, but it's still not on the projectile itself. Now, you want to go ahead and exit out of this, and you want to go back to the middle tab. Find on hit detection and go to advanced setting once again, and choose add ability unit under on hit trigger settings. Once you're here, you want to add the ability units, both of them, and the order in which you add them also matters, because what you don't want to happen is for the projectile to destroy itself before it actually does its attack. So be careful. You want it to do the attack first, and then you want them to destroy itself. After that, you're pretty much done with the projectile. Don't forget to save, and now we have a projectile that we can reference to our actual skill. Now, the next thing you want to do is to create a skill that summons the projectile or launches the projectile. To do that, you want to go to the third option on the left side, and that will take you to the skill tab. In here, you want to click on new skill. Name your skill however you want. Let's name is Pyro Launcher. Again, choose a folder you want it to be saved to and confirm create. And here you can see the skill settings that you can change. You can change the skills icon. Uh, you can choose the flame icon for this pyro launcher. The next thing you want to change is what kind of skill it is. For this project, we want to go ahead and choose aiming skill. Confirm the changes. And it will now leave us with a blank animation editor, which we'll tackle later. For now, let's go to basic settings. Enable fall protection so that when you're holding the skill button, whenever you are on the edge, you won't fall down. Um, let's allow cast in midair turned off, and that should be it. Next, we have aiming settings. I prefer hold settings, but if you want to do toggle, if you choose toggle, you will actually enter an aiming state similar to when you're using a bow user and you use the right click button. I prefer the hold button for this skill, so let's do that. Let's turn on movement while aiming. And let's just leave the aim and fire animation duration to default. Since this will be a normal attack, I will set the cooldown to off and just leave it as is for now. For the radius settings, let's keep the radius to 30 and the height to 10 meters. Once you're done with all of this, we want to go ahead and go into the animation editor. Once we're here, the first thing that we want to add is the animations. For aiming animations, you only have two options. You can either choose a bow aiming animation or a throwing animation. For this project, we're going to go ahead and choose bow aiming animation. And you can see that it automatically fills out the three tracks that is needed for this skill. The next thing we want to do is add status tracks. So your status tracks are this green section of your animation timeline. You need 4 of them for this particular project. Now, go ahead and create a new one. What you do is you right click over here and then choose new track and click new status track. Go ahead and make 2 more of those. All right. Now we have 4 of them. The first one we want to rename to aiming state. Next one we want to rename to crosshair. The third one you want to rename it to interruptions. And the fourth one we want to rename to skill release. All right. Now, once you've set that up, under aiming state, you want to right click on this section right here, add event, and choose enter aiming state. So for this particular one, we want to actually extend this out until the end of the animation. And you also want to change this depending on the camera settings of your shooting game. By default, just like in Genshin, this will turn into a first-person mode or a first-person view. So you want to change that. In my case, since I'm doing a third-person shooting game, I want to adjust the X, Y, and Z axis in order for me to show the character. For the Z axis, you want to change this to negative 3.5, right? Something like that. And then let's go ahead and change the X axis as well to, let's say, 0.75. Yeah, I think that's quite enough. We can also change the transition duration to make it a bit faster, switching between non-aiming state and aiming state. So for me, I like to set this to 0.3. 0.3. All right, so enter and exit. Now close that out, and the next thing that you want to do is add the status track for crosshair. So go ahead and add it over here. Right click on it, add event, and choose show crosshair. Now for this one, you don't really have to change any settings. You just want to make sure that you show your crosshair within the skill animation duration. All right. The next track is interruptions. You want to right click, add event, and choose allow interruption. We actually want to set this from the very beginning to the very end of your node graph in order for it to not interrupt your skill if you ever do any of these actions. So we want to turn this off actually because we don't want our skill to be interrupted when we sprint. We don't want our skill to be interrupted when we jump. We don't want our skill to be interrupted when we glide. And we don't want to interrupt our skill by moving using the WASD or whatever movement button your device is using. So let's go ahead and go turn that off and close that out. The last thing that we want to add is skill release. Go ahead and right click, add event, and choose allow skill release. So again, similar to allow interruption, let's extend that from the very beginning of your node graph to the very end of your animation timeline. All right, once you've done all of that, one, two, three, four, then we are good to go. The last thing that we need to add in the animation timeline is the node graph for your projectile itself. So as of right now, your skill is only doing the bow animations, and it's not really doing anything apart from letting you enter the aiming state, showing crosshair, and all of this stuff. Now, we want to add the event node graph that we want to put on the event track right here. So in order to do that, we want to go ahead and switch to the Miliastra sandbox. So let's go ahead and add event and open Miliastra sandbox. Once you've loaded in the Miliastra sandbox editor, you want to click on window at the top and choose client node graph resource explorer. Now everything that happens in the client should be set up here. So go ahead and choose skill node graph from the left side menu and choose a folder you want the node graph to go into. So you can create your own folder. In this case, I'll just choose the projectiles folder that I created. And anywhere in that folder, right click and choose create node graph. Right click on it and hit rename. And you can name it whatever you want, but let's just name this Pyro Orb, the same as our projectile so that it's easier to reference later on. Right? Find Pyro Orb or whatever you named it to and double click on it. It will take you to the node graph editor. And the first thing you want to do inside here is take the output pin of the node graph starts and extend that out. Release, and it will show you the node library. In the node library, you want to search for a thing called camera orientation detection data. So just choose camera. And you can see that it's already shown here, camera orientation detection data. Click that and it will add it to your node graph. For the target type, we want to set this to all except self. And then for the launch location, we actually want to reference your character's attachment point location. So anywhere in the node graph, right click and search for self. All right, it will show you get self entity. That's the one that you want. Click on that. Click on the output pin of the get self entity, extend that out. And the next thing you want to add is get attachment point location. Go ahead and click that. Now for the attachment point name, in this specific example that we're making, you want to attach it to GI underscore weapon R. Go ahead and take the GI point location and connect that to the launch location. For the nearest distance, I set this to 0. For the furthest distance, I choose 1000. After that, the next node that you want to add is something called fixed point projectile launch. So go ahead and find fixed point. All right, it should be here, fixed point projectile launch. Click that and it should add it to your node graph. Now it will ask you for the projectile's prefab ID. You want to input here the prefab ID of the projectile that we created earlier. All right, exit out and go to projectile, the local projectile folder, and find the projectile we just created, which is Pyro Orb. As you can see, the prefab ID of the projectile that we just created is over here. Click this button and it will copy it. Now go back to Miliastra Sandbox Editor, and over here you just copy your projectile's prefab ID. Next is create location. For this, you want to get the attachment point location. Click on that and attach it and connect it to create location over here. So now our projectile will launch from the GI weapon R attachment point. For the create rotation, let's just take the target rotation and connect that over here. For the projectile faction, we actually want to reference your character's own faction so that it should be the same as yours. So under self entity, connect the output pin and find a node called query entity faction. So you can find that under faction related, query entity faction, and it will take whatever your self's faction is, connect that to the projectile launch, and now all of your projectiles will be the same faction as you. Click on Save. Now we can go back to the editor. Go back to the skill editor, find your skill, and choose Animation Editor. Once you're back, we want to test if your node graph is actually working. So before we do that, make sure that your branch track, the response one transitions to default branch, basically at the end of this. Now under node graph event track, the purple part or the purple section of your animation editor or animation timeline, right click on that and add event. Find the node graph that you just created. So in this case, we have projectiles, pyro orb. All right, and we just lined it up at the end of your animation. Now we want to test this out, so go ahead and exit out. Don't forget to save right here. After saving, you also want to make sure that the scale is attached to the player. Now go to class, and for now, let's just attach it to your default class. Click on the middle tab right here. Let's assign it to your character's normal tag. Click on here and find the skill or that we just created, Pyro Launcher, and you'll be good to go. Now click Save and test play it. Alright, seems like our projectile is working. Alright, so we're pretty much done with our projectiles. So for the last part of this video, I will be talking about two things. One, how to achieve rapid fire rate, and number two, how to simulate hit scan or insta hits. Alright, so for the first one, the rapid fire rate. Now, for this one, we want to stay in the animation editor. And the only thing that you really need to do is to copy this pyro orb event node graph that we created, and copy it as often as your fire rate is. So say for example, we take a fire rate of 10 rounds per second. That means that every 0.1 seconds, this node graph should be triggered. Another thing we have to change is the duration of the loop animation. This duration determines how long this loop animation will play before it moves on to the next branch or to the next animation in the animation timeline. Now, if our skills fire rate is 10 rounds per second, that means if I set this to 2 seconds and I copy this event every 0.1 seconds, that should give me 20 rounds in total per skill use. With the same fire rate, if you set this to 3, that means per skill use, you'll have 30 rounds in total. Let's go ahead and set this to 3, and then we'll go about copying and pasting this node graph. Right, let's move our finder to 0.1 seconds and paste here your node graph event. For more precise editing, you might want to adjust the zoom of your animation timeline. You can set it up to like this. Now you can see every line per 0.1 seconds more clearly. Now continue copying and pasting it every 0.1 seconds. So paste 0.30, paste 0.4. Alright, so this is probably the most tedious part of this video, so I just fast forwarded it. Alright, that should be it. Since we increased the duration of our loop animation, we also have to adjust the endpoints of our status tracks. We want the aiming state and the crosshair to be at the very end of the loop animation. Right there. And for our interruption and skill release, we want the endpoints to be at the very end of the animation timeline. Now we want to go ahead and test this out. Don't forget to save and do a test play. All right, that seems to be working.
Yeah.
All right, so for the last part of this video, we'll be looking into simulating a hit scan or insta hit on your projectiles. Now, for this to work, we need to actually make two projectiles. One is the one that you already made, and the second one is basically just a visual effect that doesn't do any damage. To make our lives easier, let's just go ahead and use the same projectile, save it as a new file, and name this Pyro VFX. Confirm create. And the only thing that we really need to remove from this VFX projectile is the hitbox attack, because this is just a visual effects and should not deal damage. All right, this will all make sense later once we go back to the Miliastra sandbox editor. Right, go ahead and save that. And also, so we don't have to come back here, go ahead and copy the prefab ID of the Pyro VFX. Now let's go back to the Miliastra sandbox editor, and we want to open the same event node graph that we used for our skill. Now, one of the changes that you want to do here is you want to add the uh, projectile launch of your VFX projectile as well. So go ahead and take the output pin of the camera orientation detection data, extend that out to the other side, and go find the same node, fixed point projectile launch. And for the projectile prefab ID, since you've already copied it, let's just go ahead and paste it here. For the create location, since this is the visual effects that you want that is coming out from your weapon R right here, you want to get the attachment point location and connect that to the create location and the target rotation to the create location. Same thing as well, you want to get the faction and attach that over here. Now, the second thing that we want to change is this is our projectile that deals damage. Instead of the create location being from the attachment point location, we actually want to launch the projectile directly to the target. So you want to get the target location output pin from the camera orientation detection data, and that is what you want to connect to the create location. The target rotation remains the same. And what this does is basically whatever your camera is targeting, that would be the launch location of your damaging projectile. And so in essence, it is creating a instant hit that once you press the button, it launches directly to the target so that your projectile doesn't have to travel. Once that is done, you want to go ahead and click the save button, go back to the main editor, and we're going to test it out. I'm not sure if you could notice, but instead of it waiting for the projectile to arrive at the target to deal damage, it instantly deals that damage. So maybe if we go farther out, you might notice it more. Here's another test play of the projectile that we just created, and we will be implementing it with the prefab resource that I made in Miliastra Wonderland. This one is a projectile launcher weapon that I created. The link will be in the description down below if you want to give it a try. So let's try and equip this weapon and see how the projectile looks with the weapon that we just imported. Alright, so that's how it should look in game. Pretty sick. Alright, and yeah, that's our projectile. That concludes our video for today. I hope after this you will be able to create your very own projectile for your very own shooting games, and I can't wait to test them out as well. So good luck and have fun.